This is the second video about this sculpting problem where you do not have a constant DSCR, where you have a curved DSCR, where the bank or the term sheet gives you the size of the debt, the DSCR, and the debt life, but it doesn't give you the period-by-period repayments. You as a modeler have to do this. Now, in this video, I'm going to show you a different method for this. My objective in this is to get this to the point, and I am very close, I promise you, to get this to the point where you can implement the sort of things I'm going to say into real large models. Again, the first thing is to understand the problem. And I, again, am thanking Heidi again for this. I didn't, Hadea, sorry. I'm going to talk about this method of using a function which really is a different way to think about modeling, a different way to think about Excel. And I want to show you how you can do this, use this technique of user-defined functions, and I really want this to, for me, this is a real innovation, I hope. And what I want you to do is to say, oh man, that is pretty cool, and then say, oh, I better take one of his webinar courses for this. That's what I want. I'm not just doing this totally as an idiot, because my business sucks right now. Okay? Now, when you download this file, and in the last video, this is a second part of a video. I kind of went through some of these earlier videos. In this one, when you download this file, after you've tried it with Solver, tried it with GoalSeek, and you'll get circular references, and you can try to, you hit the Solver thing a bunch of times. Half the time it wouldn't work, sometimes it would, you'd be really happy, other times it wouldn't. You have a big model that clunks around. In this method, here's what we're going to do. We're going to be able to change parameters, and I hope to explain through illustrating the model a couple of things. My objectives are to show you the importance of getting around and getting past some of the limitations of Excel by writing a little code yourself. Sorry about this. I know I have people who say, oh, no, VBM, no. Screw it. This is just, it's just doing some real modeling in a different way to prevent the things in Excel that break. So when you download this file, you click on this one. Okay, up here, you download this file, okay, right here. And then when you download it, I just did this, you get this thing. Okay. And here we are. Okay, and I'm going to save this. This is exactly the version I'm going to put on the website. And there are more complicated things in this, and if you really want to get into the details, which I think you should, if you're really a modeler, you can take a webinar class that I'm about to structure. Now in this case, I started with a case. As before, I said, oh, we could have a flat DSCR. Now, the only way I could kind of do the flat DSCR for now is I put a 0% tax rate. So I have a simple flat DSCR, which is this LLCR method I talked about, where the LLCR is the cash flow PV of cash flow divided by debt. And the LLCR is the same as the DSCR if the DSCR is constant. And this thing is about having a non-constant DSCR. So in this scenario that I have, I put in a minimum DSCR of 1.5. The LLCR would have given you 1.9. So the DSCR goes down to 1.5. But it starts higher. And when it starts higher, the net present value of the debt, somewhere down here, this net present value is exactly what you're aiming for. Okay, well, okay, 549.98. I have to maybe do a tiny bit more iteration to get it exactly right. So we sculpt with these curved DSCRs, we get this amount of debt. And how do we know that we shouldn't have kind of made the slope steeper or started here and made a curved DSCR or whatever? And the reason the curvature is defined by the debt life. And right now in this scenario, I hope that the debt life is debt balance. The debt life is 15.09. Oh, I'm sorry, I missed it by a tiny little bit because there's a little bit of iteration going on here. All right. If you just even understand this problem, I think you're ahead of a whole lot of people in the project finance world. If you understand that there are two constraints, the minimum DSCR and the average debt life, and that defines the curvature of the debt. Now, the technical issues in getting this right are difficult, and I'm not going through those. I'm just going to kind of show you how it works. Now, let's say I put in a 15.5 times a 15.5 year debt life, because the tenor, where was the tenor? The tenor was 20 years. So debt life has to be less than the tenor. It says, yeah, we got a success. I had to put wow here. And if I go back to 15.1, I think. 15.1, if you look at the equity IRR, it's 10.37. 15.5, oops. Okay, sorry about that. It went up to 10.44, maybe not a dramatic increase. And then what happens if we change the DSCR to 1.3? Then you can see we get a different curvature. That didn't help much at all. The debt life was more important. What if we put 16 times debt life? Then we're starting to get a higher DSCR. Now we put 1.2 in, and then it's similar. And what happens if we put 117.5 in here? Then you start to get a funny looking debt repayment pattern, and maybe this is a little too extreme. And you have to go and negotiate with a bank and see if they'll agree to this sort of debt repayment structure, which I doubt. So we put 17 back, I don't know, 1.1. Okay, 1.3. There we go. Maybe this is what we finally agree with. And you say, it's not much higher than this, but it is higher. And that's how you do some sculpting. Of course, if you change things around a little, let me put a little bit of a lower project cost in here. Okay, now we'll get, how about 850? Okay, we get a higher equity IRR. If we're in this kind of higher equity IRR, which of course I think is maybe unrealistic, then we put our 15 in, and then we get 13.67. I'm always looking at the equity IRR. We put 17 in. We got 14.2. It made a little bit of difference. Maybe it's too aggressive. Maybe 16.5. And you want to do this. This has circular references galore because the sculpting is driven by the taxes. I didn't even put the tax rate in, but the interest on the sculpting goes into this, and it's got circular references with the LLCR calculation and other things. Now, to do this, what you would have to do is, what I do is I basically redo the whole model. This is a user-defined function called optimize. Now, this is just the first part of it. You really want to know how this works? You can do two things. Take the free model, study the heck out of it, or take it like this, and you once you have this function, it's just like a sum function or more like a transpose function. You press Shift Control Enter. What you have to do is get a hold of this function, put it in your model, or put it in maybe a part of your model, and it gives you all the cash flow. It works through all the circular references. And if you notice, when I do this, it says take line 14 to line 33. And line 14 to line 33 are all of these inputs that drive the function. Now, you might be saying, oh my God, that's like learning some kind of programming language called R or something like this. Well, you don't have to do it. You have to take a kind of template analysis, and you can adjust these things, and you can become completely different. You can become so more advanced than all this other rubbish shit you get out there. Sorry about saying that swear word, but you could really do something a little bit different on this. Now, this is just an introduction. I am going to show you how to integrate this, integrate all of the other complexities. There's a complexity where you take the DSCR and you add changes to the DSRA, debt service reserve account changes go into the denominator, not the numerator of the DSCR. I'll explain the theory of that. And that creates an enormous circular reference, and you can solve it all with this user function. And you try to do this with your copy and go seeks and your paste, copy paste special, and it's a disaster. So, enough. You press Shift Control Enter and you're finished. And that's the general process, and that's enough of this video. Again, I haven't announced the dates for the webinar, and I'm going to make it a couple of different. I'm going to make not one kind of, you can choose different times, and we're going to limit the number of people who can come and watch this, limit it strictly, and we're going to get something so you can see how to realistically implement and really understand some of this stuff, going from the start of making a user-defined function all the way to the end.